Okay, in this video we're going to explore the line. Now we know that any 2 points define a line. And if we have 2 points, we can connect the dots and then we have a line. We have different types of lines. We have horizontal lines of the form y equals c. We have vertical lines of the form x equals c. And then some of the more interesting lines are the lines with what we say have some tilt to them. So what exactly is this tilt? Well, the tilt refers to the slope of a line. Right? We're going to use the letter M to represent slope. And it measures the change in y as x changes. Right? So if y gets bigger as x gets bigger, then our line has a positive slope. And it looks like it grows as x moves to the right down the number line. Right? So as x gets bigger, y gets bigger. It's a line with positive slope. If y gets smaller as x gets bigger, then the line has negative slope. And so it's a falling line. As x moves to the right down the number line, y drops. Right? X gets bigger, y gets smaller. That's a line with negative slope. Now if y doesn't change at all, that is, remains constant as x gets bigger, then the line has zero slope. Lastly, if x remains constant or unchanged as y changes, then the line has undefined slope. That's our vertical lines. Remember, the lines are the form x equals c. So in those cases, our slope is undefined. Now, you really want to refrain from using the words no slope, as it is unclear if the meaning is zero slope or undefined slope. And as we have seen, those are two very different things. So from now, henceforth, you shall not use the words this line has no slope. All right, let's explore what this does to the graph of our line. So let's first consider the line that passes through the origin and goes through all the points AA, right? So 1, 1, 2, 2, negative 1, negative 1. This passes through the origin, and this represents the line y equals x. Right? So for every x, y matches that, and plotting all those points is the line y equals x. And as we see, as x gets bigger by 1 unit, y gets bigger by 1 unit. In this case, the slope of our line is 1. Easy enough. All right, now consider a new line. Let's consider the line y equals 2x. It's passing through 1, 2, so it's got a steeper slope, right? And what do we see? As x increases by 1 unit, y increases by 2 units. This line has slope 2. Excellent. All right, now let's look at another one. Let's look at the line y equals negative 1/2 x. See, all these lines are passing through the origin. This one is falling down. As x increases by 1 unit, y decreases by 1/2. The slope of this line is negative 1/2. Easy enough. All right, so any line that passes through the origin has the form y equals mx, where m represents the slope of that line. Excellent. Now what happens if we shift the line up or down? So let's consider the line y equals x plus 1. We're going to start first with the line y equals x. Now y equals x plus 1 just shifts that line up by 1 unit. It has the same slope, which is 1, but this time it crosses the y-axis at y equals 1. Now what about the line y equals x minus 2? Again, we start with y equals x, but this time we shift it down 2 units, and it crosses the y-axis at y equals negative 2. All right, let's start with a new line. What about the line y equals 2x plus 4? So we're going to start with the line y equals 2x this time. So it has, remember from before, passes through the origin with slope 2, and we're going to shift it up 4 units. All right, so it passes through the y-axis at 4. So here, my slope is 2, and where it crosses the y-axis, called our y-intercept, is 4. So in general, an equation of a line in the form y equals mx plus b, this is m represents our slope, and b represents the y-intercept, the place where it crosses the y-axis. This is called the slope-intercept form of a line. Very important. All right, sometimes a line is given to us in standard form, and that is ax plus by equals c. This is a common or standard form of a line. We can always get that line into slope-intercept form simply by solving for y, right? So isolate y algebraically, and now you've transformed your line in standard form to slope-intercept form. So let's look at an example. So if we have the line 2x plus 4y equals 6, we solve for y, get it into the form y equals negative 1/2 x plus 3/2, and we see the slope is negative 1/2, and the y-intercept is 3/2. Easy enough. How do we in general calculate the slope? So in the examples we've seen here, I've given you a line, and we can visualize the slope. But if I have 2 points and I want to figure out what the line is, can I figure out what my slope is? So recall, the slope measures the change in y as x changes. So m equals the change in y over the change in x. Right? The difference in my y's over the difference in my x's. It's measuring that ratio. Where, so if we say m is equal to y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are 2 points on the line, we take their difference and the ratio, we get the slope of the line. So for example, let's say we have 2 points, or so if a line passes through these 2 points, negative 2, 1 and 3, 5, then the slope, we can easily calculate, is 4/5. And what does that mean? As x increases by 5 units, y increases by 4 units. Excellent. Now, from the slope equation, change in y over the change in x, we get another useful equation, actually a very useful equation in calculus, of a line. So suppose the slope of a given line is m, and we know one point, x1, y1, on that line. Then for every other point, xy, on that line, then it satisfies our slope equation, right? So m equals y minus y1 over x minus x1 for any point on the line. That's what it means to have that slope. If we do cross multiplication, we get this equation. The slope times the change in x equals the change in y, which we often write in the other order. And that's called the point slope formula of a line, right? Y minus y1 equals m times x minus x1. That is the point slope formula of a line. Let's look at an example. All right, so find the equation, and we're going to write this in slope-intercept form, of a line passing through the point 2, 3 with slope equal to 1/2. All right, so we're going to express that in slope-intercept form. So we start with our point slope formula, and we plug in the point 2, 3 for x1, y1. So y minus 3 equals my slope times x minus 2. We perform our algebra, isolate our y, and it's in slope-intercept form, and now we can easily see that our slope is 1/2 and our y-intercept is 2. Fabulous.